Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Now we move to section 5.3 quadratic equation. So in this section we'll be focusing on solving equation that is more complicated. This is called quadratic equation because our x here has exponent 2. So we are interested in solving the unknown quantity x. In this case, a cannot be 0 because if a is 0, then the equation is reduced to a linear equation. A quadratic equation, like I said just now, because the highest exponent of x is 2, therefore it is also known as the second degree equation. So basically there are three ways to solve a quadratic equation. The simplest is, for me, is using the quadratic formula. Second is factoring. If the quadratic equation is simple enough, then you can some sort of see it and factor it quite easily. And the third one is completing the square. Okay, in this order, we're going to show first the first method, which is solving the quadratic equation by factoring. So this is actually a very easy method, but the application is a bit limited because the equation is not exactly very easy to be solved by inspecting or just by seeing it. But anyway, how can we solve this quadratic equation is by changing the form of quadratic equation into a multiplication of two items here. And how do we get this value? P, Q, R, and S? That is purely by inspection or try and error. Because of the zero product property, we can say that Px plus Q must be equal to 0, or Rx plus S must be equal to 0. Now, zero product property is already discussed in chapter 1. Okay, for example, if you have A times B equals to 0, you can say that either A is 0 or B is 0. Now, once you have managed to solve these two equations, you'll be able to obtain the roots of the quadratic equation. And the final step is to check whether the solutions obtained are correct. Okay, let's look at example 5.10 on how we can use factoring method to solve this quadratic equation. So for A, x squared plus 9x is equal to 0. Now you can easily factor x out. So x plus 9 is equal to 0. And using the zero product property, that means x is equal to 0 or x plus 9 must be equal to 0. This one is done, and this one is x must be equal to -9. So that's the answer. Okay, these are the roots of the quadratic equation, x0 and x -9. Of course, you can check, okay, whether this is true or not. If you substitute x into this, you will get that this will become 0 squared plus 9 times 0, which is 0. So left hand side is equal to right hand side. And similarly, if you substitute -9 into this, so you will get -9 squared plus 9 -9 is equal to 81 minus 81. This is also 0. So you can see that the solutions are correct. Okay, next. 2x squared is equal to x plus 3. So 2x squared is equal to x plus 3. Now, maybe what I can do is I rearrange the expression. So it looks like 2x squared minus x minus 3 is equal to 0. So basically, if you want to inspect the quadratic equation, you know that I need to find the right combination so that I get the expression of 2x squared minus x minus 3. So for example, this is 2x and this is x. So when I multiply them, I will get 2x squared. So if I multiply them, I'll get 2x squared. I'm going to find a combination of 3 such that when I multiply these two values, I'll get 3. So maybe what I can do is this could be 1, this could be 3. So when I multiply, I will get 1 times 3 is 3. But I need to have a negative value over here. So what I need to do is I need to consider a combination of positive and negative, and this could be negative 3, this could be positive 1. So if I multiply a positive 1 with negative 3, I will get negative 3. And then how do we get the middle part here? The middle part here is obtained by multiplying this guy, 2x with 1 and x with negative 3. So here you will get 2x minus 3x, which will be x. So based on this quadratic equation, I can actually write it in the following form. 2x minus 3 times x plus 1 is equal to 0. You can always check whether this is true or not by expanding by expanding the terms. So for example, 2x times x, I will get 2x squared. 2x times 1, I will get plus 2x. Negative 3 times x, I will get negative 3x. Negative 3 times 1, I will get negative 3. And that can be simplified as 2x squared minus x minus 3, which is what we have over here, the original expression we have over here. So by inspection, I am able to write the quadratic equation in terms of 2x minus 3 here multiply with x plus 1. Now using the zero product property, I can say that I can say that 2x minus 3 is equal to 0, or x plus 1 must be equal to 0. And solve it separately. 2x is 3, x must be 3 over 2. And over here is x must be negative 1. So this is these are the answers to question B, and I leave it to you guys to check whether the solutions obtained are correct or not. As for question C, I'm giving you the answers here, but you can do it on your own. So the answer is x is equal to negative 3 and x is equal to 7. Okay, next. Okay, now we move on to the second method of completing the square. So the first step in completing the square is whenever you have the quadratic equation, make sure that it is written in this standard form. 8x squared plus bx plus c is equal to 0. And when you have that, the first step is to divide that quadratic equation with a. So this is what you will get after you divide the whole thing with a. So okay, ax squared plus bx plus c equals to 0. Divide the whole thing with a, divide the whole thing with a. Then you will have x squared plus b over ax plus c over a is equal to 0. So that is what you have over here. And then move the term c over a to the right side of the equation. So this is the term. So move it to the right side of the equation. Okay. Next, complete the square. So when you move it to the right side of the equation, it will become x squared plus b over ax is equal to negative c over a. And then complete the square on the left side of the equation and balance it by adding the same value to the right side of the equation. So once you do that, the result will look like this. Something similar to this. X plus p squared is equal to q. Now, the aim is to solve x. Therefore, you have to get rid of the exponent on top there. So how do we get rid of exponent? We can introduce the square root. So we take the square root on both sides of the equation, and this is what you will get. X plus p is equal to plus minus square root of q, and then you can get the value of x by letting p to be moved to the right hand side. Subtract the number that remains on the left side of the equation in order to find x. Well, at one glance, maybe to those who haven't actually familiar with completing the square method, it can be overwhelming. But worry not, we are going to show it to you. I'm going to show it to you through this example here. Okay, so the first example, A. Okay, so here we have x squared plus 5x plus 4 is equal to 0. This is already in a good form. Okay, so we don't need to do anything about it, and we also don't need to divide with a. Our a is 1. Our a is 1. If you divide anything with 1, you will get the same thing. So we are done on that part. So now we are going to make sure that this term is on the right hand side. So that means x squared plus 5x is equal to negative 4. Now we can move on to the next step, which is complete the square. Complete the square meaning that I'm going to replace this with something that looks like x plus p squared. So this is our aim. Okay, we're going to replace x squared plus 5x with something that looks like x plus p squared. So how are we going to do this? Now there is a simple trick in doing this. Okay, so the trick is that if I have x squared plus 5x, so I will always use this number. This is our b, so b. So I can always express that in terms of x plus b over 2 square. This is a simple trick, x plus b over 2 square, in order to get this kind of form. Okay, now what happens if we substitute b with 5? So that will be x plus 5 over 2 square. Now what is exactly x plus 5 over 2 square? If you expand this, you can see that it becomes x squared plus 2 times 5 over 2x plus 25 over 4. So you can cancel this, then it becomes x squared plus 5x plus 25 over 4. Now again, recall that we are aiming to replace this with something that has a bracket, something inside, and a square on top. So what I can do is I can replace x squared plus 5x with this guy over here. So it becomes x plus 5 over 2 x square. Okay, x plus 5 over 2 square. So now it looks something similar to this one. However, I cannot just stop at that, because as you can see here, if you expand x plus 5 over 2 square, you will get something different, not exactly similar to the original expression. Original expression is x squared plus 5x, But if you substitute that with x plus 5 over 2 square, you will get this additional term that is not originally there. So what are we going to do? This is what it means by this statement. You balance it by adding the same value to the right side of the equation. You make sure that it is balanced and it is correct. Okay, so now if I have additional value 25 over 4, I can get rid of that by introducing negative 25 over 4. And that is equal to negative 4. So this is original statement. That original statement is the same thing as this second statement over here. Okay, so now that will become x plus 5 over 2 square is equal to negative 4 plus 25 over 4. So next, what happened is that negative 4 plus 25 over 4 is just 9 over 4. 9 over 4. Now, if I want to get rid of the exponent, I need to introduce square root. So now, I'm going to write it here. So now, x plus 5 over 2 is equal to 9 over 4 plus minus. Then x plus 5 over 2 is equal to plus minus 3 over 2. Therefore, x is negative 5 over 2 plus minus 3 over 2. So we have two answers here. Okay, you can easily calculate what the answer is. The answer will be x is negative 5 over 2 plus 3 over 2, or x is negative 5 over 2 minus 3 over 2. So over here the answer is negative 1, or the answer is negative 4. Okay, right, thank you very much. We'll continue this in the next video.